All right, let's get into AWS with Rust here. What I'm going to take a look at today is this distro list stuff, which is pretty interesting. I learned about this from Maxim David, who's the first person that told me about this. And it's pretty cool because it makes these really, really tiny images. And so you can see the smallest distro list is like 2 megabytes, which is crazy. So I'm going to play around with this a couple different ways. So the first thing that I'm going to do is just build it quickly. So let's just get something working. So I'm going to go to code, go to code space and just launch a code space I have and just dive right into this. The other thing that I want to do simultaneous to that is also get into Cloud9 and play around with Code Whisper and also ChatGPT and see how that could maybe help me. So I guess the first thing that I can do here is I'm going to dive into making a new project, and we'll just call this one um, cargo dist, and we'll call, I guess it could be distroless CLI. Let's try that first. Let's make like a super tiny command line tool. So we'll say cargo new distroless CLI. So first up, what I'll do is I'll cd into this distroless CLI, and I'm going to look at the code here and just add. Let's look at another app I have somewhere, Marco Polo. Here, let's do that. Marco Polo CLI, which would be, here we go. Yeah, I'm just gonna grab a previous cargo file to just make sure I've got it going. And I can just cp a make file as well from something near me like dedupe make file. There we go. And then under the main, let's just really quick build out also grab a little bit of something from there as well. So we can do maybe something like this. Let's just put it on one file here. So command line tool, and we'll call this one. This is just like we'll just make a hello world to keep it simple. And we can say greet here. Yeah, keep it super simple. And then to build it out, doesn't need to do much. That results hello world. Now I think in this case, let's see here, we have hello main, hello world main. I think this looks kind of like what we want, but let's compile it real quick. Lint it. And that's exactly what I thought. So in this case, we actually don't need that. Let results. We can actually say here, hello results. Don't need to do anything. No, hello. In this case, it would be name. Exactly. There you go. Expected expression. There you go. Now if we say cargo run, we can run this. We can say help. Oops. Cargo run. And we can say greet Bob. Oh, greet dash name Bob. Hello, Bob. Okay, we got it working. In fact, I could just add that to make file. We don't need that. So run. We can do that. Okay, so now let's get a super tiny container, and what I'm going to do is I'm going to copy another one that I had previously. Type file, and we go here, and let's just double check Rust. It looks good. So we're going to use from distrolist, and we're going to call this something a little bit different in that we're just going to call this one CLI. We'll call this one CLI command. Now, what I don't know is, well, whether how this will accept parameters will be interesting. I mean, I guess I can just build it. We'll just say Docker build. Let's build it out and see what happens. So the idea here is that this is a beefy build process in that it uses like a regular Rust Docker container, but then it will push those into GCR into this distro list to make it super, super tiny. And in fact, while that's running, you can see some of the different flags here that people use. And they may even have some examples here. Examples, Python 3. Ooh, look at this, Rust. They even have a Rust example, which is, I might actually try that. Let's see. Hello World distro list. And what's in their cargo? Dependencies. And if we look at the source, what's inside of here? Oh, just hello world. Not much. Okay, but let's see what happens here. So again, this is going to build this super tiny Docker file, which I think it can even be optimized further with cargo commands and all kinds of stuff. Like if we wanted to make it a smaller binary. But let's start with this. Yeah, I always screw up when I make Docker files, whether they accept input. Failed to compute. Because that's not the name of the project. So the name of the project is this distrolist CLI. So let's just make this simple. Dist CLI. Let's make it really simple. And then go here, build release, release. It's got to be the same thing. There you go. Build it. So it's building this release, and then we can see what the size is of it in just a second here. And this machine is reasonably powerful. We open up another window here, we can see that it's got a 6-core machine. There we go. And it's got quite a bit of memory. So it's not like a 16 core, but it's got a decent amount. And we can see when it's compiling that it is actually using all the cores. So more cores. This is a GPU based instance, would be better. Okay, so we got it. Now the trick is Docker image ls. We see that in fact this is tiny, 27 megabyte Docker container image, which is super tiny. So then we say Docker run -it this, and then what does that do? No subcommand use. But if I pass in -- and then I say help, what does that do? Okay. Yeah, so I always screw this up with Docker, how to pass in the well, actually, let's ask ChatGPT. Say, I have a Docker distillus image with a binary CLI tool, and I want to pass in user input. What is the Docker command? See if this works. All right, let's take a look. Just thinking. To run it with a distillus image and pass user input to the binary, you can use Docker run command with -it flag, which stands for interactive, and sudo terminal. Here's an example. All right, let's see. Docker run -it rm binaries. Okay. Command or args. Binary C. Well, that don't think that is exactly. Well, while that's running, let's try it out. So if I do this, I say -rm. If I say /dist CLI, what does that do? Oh, okay. How about this? Oh, there we go. So it worked. So now read name Bob. Cool, not bad. Okay, so that was helpful. I got that info from my friend here, ChatGPT. So let's go to MB. Now let's just say to run the 24 megabyte binary. Do this. Now I'm curious how to make it tinier. So let's ask ChatGPT here as well. So how can I make the Docker image smaller via Rust compilation? See if it has any tips. So it's thinking here. What do we got? Here's some tips. Okay, we want to go even smaller. Would be use a small. We already did that. Well, while that's working, because it's going to take a little bit, I'm going to check this in. So we can see again the idea here is that it made a 27 megabyte binary, which is awesome. We'll say 27, which is pretty cool. So I'm going to check this in. So git add to this CLI, adding small CLI. So that was pretty slick actually. Now let's also run this in AWS. And so I'm going to go to Cloud9 and I'm going to I'm going to create a new environment for Rust. We'll say Rust multicore environment. We'll say this environment uses mini cores to compile. For this, then I can kind of start to go back and forth and even potentially deploy a distroless Lambda. So I want a lot of cores. So what do we got here? I want at least 16 core, maybe 32. Now this 16, let's see here. What do we got? A lot of 16 core machines, 64 gigs of RAM. Probably this M5, although memory versus CPU, I'm going to go CPU. I want this one looks pretty good. C5X 4X large. So let's get that one. And let's go ahead and create. And while this is waiting, I'll go back to ChatGPT and it says, oh, okay, so let's see here. So you can do, so instead of using a smaller base image, we can do that, which is what we did. Use LTO link time optimization in your cargo file. Okay, let's try it out. And also strip the debug symbols as well from the binary when building it. Add, export Rust flags. So let's add that to, let's go to our cargo file and let's just double check what it's saying here. Let's look. So it says profile release. So we want to add a profile release. And I guess what I could do is we could call like a build Docker. Say Docker build distroless. We want to export that command, strip the debug flags. So I think we want to do something like this. So we want to say export ask ChatGPT, say is this file command correct to optimize? See what it says. A little bit sluggish, but it eventually gives us good stuff. Export Rust flags, C-link. So basically get rid of the debug symbols from the binary. And then we're going to use this profile release. So I'm kind of curious what the different size will be if I do this. It's definitely hanging for a little bit. So while it's waiting, I'll go back to this repo. Where's this? Go to GitHub. Let's go to, where's the link to the repo? Well, we can just go to this repo here. Just grab it so I can clone it. And I'm just going to do HTTP clone so I don't have to worry about keys. So let's go here. We have Rust multicore. I open it up, and this is a monster machine here that I'm going to work with. There we go. So we see it's super powerful. I'm going to do two things in order to use AWS. One, I'm going to use Rust up. So before I do that, though, let me first clone the repo. So git clone. There you go. I'm going to cd into this repo. And I'm going to run Rust up. And this should be quick because it's a powerful machine. I'm going to get this thing cooking here, and we could even do another. We could even open up another terminal to do htop, just or top. See, oh, that was quick. So it was already done, and it's already in the directory. Everything's ready to go. Okay, so we go back here, and it might be better to use directly in the Docker file. Build Rust flags. Huh, that's interesting. Oh, interesting. Let's try that out. So that's amazing advice here. So we can go back to our Docker file here. And we can put this here. And then we can again go to, or if you prefer using a build argument, so you could put in the Docker file. So we already put it in here. So we don't, yeah. So I think this is actually pretty good. I like that, those Rust flags. And then for the make file, we can just do this. So let's try it again here. Let's do make build Docker. Remember, if we say Docker image ls, it was 27. Can we get it smaller? Let's try. So make build Docker. Ooh. cd into it is distroless CLI. Docker. And it would be nice if I had a more powerful machine here. But let's see what happens. Meanwhile, I could do the same thing on AWS. So let's go over here. Well, that's because it's going to take a few minutes. Let's go over here and let's cd into the distroless CLI. And in fact, while this is compiling, I can go and say git add distroless CLI. Let's check it in. Adding new compile flags. And push. And then we can go here and we can do git pull. Okay, we got that. So if I just say, if I look at the make file here, distroless CLI, right? We'll just say make build Docker. Build Docker. I bet you this will be pretty quick. And it's got so many cores. We could even put it right here. We could do op. See how beefy this thing is. Now, what would be kind of cool actually would be to do yum sudo yum install htop. Whoops, htop. So I have a better monitoring tool. There we go. And now I can do htop. So we can see the compilation process. And then if we go back to here and we go to this other, you see this thing's still cooking. But uh-oh. What is it? Oh, I see. Options are incompatible. So we have, well, I don't, because inside this cargo, we're already doing these. I don't think we need those. So what we can do is, let's go back to what it told me to do. So it said C-link. I think that's the only thing we need is C-link. So well, actually, let's just strip this because we already have some pretty good optimizations. Let's do it again. And we know that was the same problem here. So let's go again to the Docker file and let's rip that out. We don't need that. There you go. And we can just recompile. So this does look very fast. This 16 core machine looks very beefy. And so this will probably finish much quicker than the other one. Okay, yeah, this thing's still cooking, 40 seconds. And this one is going through and building a release. We can see, in fact, it's surprising that it's only using one core right now, which is kind of interesting. I'm not sure if you do release optimizations if it uses less cores. And if we go back here, this thing's still cooking as well. Okay, now it's downloading the crates. We go to this one. I guess it's still building the crates. Okay, now it's downloading the crates. Now it's using all the cores. Now it's compiling. But again, it's stuck on. It's interesting that it's not using all the cores. Oh, well, that was quick. So it only took 1 minute to compile. Now it's putting it into the binary. Okay, so I'm very curious now. Let's take a look at here. We can get rid of this thing here. So if I go to Docker image ls, see so it did make it a little bit tinier. So it's 20. So it did shrink it. So it did make it 24 megabytes. But if you look at this, the distro list itself is 22, right? So it's only a couple megabytes inside of here. I mean, this is a tiny binary here. So not bad. If we go back here, we see the same thing. We can say Docker image ls and 20. So yeah, that's a good. So these flags are pretty good here. These when you do profile release, it does actually make it a lot smaller. Now I haven't tried the debug symbols, removing those if that makes it even tinier. But I mean, this is so small. Who cares? So I guess the other thing that would be kind of fun to try would be to see um, inside of here if we could do anything with serverless now. And how could we do this? Well, we could install cargo and see if we could make a very tiny we could do a web service, I guess, but that might be a little bit too involved here. But I guess that was the first thing that I wanted to test out, was what that process was like to build distroless and also to build it with Cloud9. It looks like it's a pretty good process here. So I think I'll call it a day for this particular task. So the next action item would be to use distroless to build really tiny binaries that get deployed to container-based services on AWS. All right, that's it for today.